Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. I'd like to start off this show by sending out a huge thank you to everyone listening. We've dropped a ton of great interviews over the past few weeks, and through your dedication, we continue to see a growing outpouring of feedback, comments, and shares with each release. If you're a regular listener, but don't normally send in feedback, we'd really love to hear from you. So please head on over to Apple Podcasts or wherever you listen and leave us a review. A 5-star review is of course appreciated, but what's most important is that your voice is heard. It lets us know what you like or what you feel we can improve on, and it also lets those looking for a new machine learning and AI podcast know that they should join the TWiML community. Speaking of community, the details of our next TWiML online meetup have been posted. On Tuesday, November 14th at 3 p.m. Pacific Time, we'll be joined by Kevin T., who will be presenting his paper, Active Preference Learning for Personalized Portfolio Construction. If you've already registered for the meetup, you should have received an invitation with all the details. If you still need to register, head on over to twimlai.com/meetup to do so. We hope to see you there. Now, as some of you may know, we spent a few days last week in New York City hosted by our great friends at NYU Future Labs. About 6 months ago, we covered their inaugural AI Summit, an event they hosted to showcase the startups in the first batch of their AI Nexus Lab program, as well as the impressive AI talent in the New York City ecosystem. Well, we were more than excited when we found out they would be having a second summit so soon. This time, we had the pleasure of interviewing the 4 startups of the second AI Nexus Lab batch: Mount Cleverest, Bite.ai, Second Mind, and Bowtie Labs. We also interviewed a bunch of the speakers from the event, and we'll be sharing those discussions over the upcoming weeks. In this episode, you'll hear from Bite.ai, a startup founded by Vinay Anantharaman and Michal Wolski, founders who met working at Clarifai, another NYU Future Labs alumni company, whose CEO Matt Zeiler I interviewed on TWiML Talk number 22. Byte is using conversational neural networks and other machine learning to help computers understand and reason about food. Their product is an app called Bitesnap, which provides users with detailed nutritional information about the food they're about to eat using just a photo and a serving size. We dive into the details of their app and service, the machine learning models and pipeline that enable it, and how they plan to compete with other apps targeting dieters, and more. All right, everyone. I am here at NYU Future Labs in New York City, and I am with the co-founders of Bite.ai. In particular, I'm with Vinay Anantharaman and Michal Wolski. Guys, welcome to This Week in Machine Learning and AI.
Yeah, thanks for having us.
Yeah, thank you for having us.
Awesome. Why don't we get started by having you tell us a little bit about your backgrounds, and from there we'll get to what the company's up to.
Cool. As I was introduced, my name is Vinay, and I kind of work on data infrastructure. And for the last about 10 years, I've been crawling the web, trying to turn that into structured data. And currently what we're working on is building a food intelligence platform that can understand the world's food.
Okay.
So I'm Michael. Actually, the two of us met here in this building at Clarifai. We're the first 2 employees. And got to work there together for 2 years before starting this company.
Okay.
Before joining Clarifai, I was at Columbia studying applied math and computer science with a focus on computer vision.
Okay. Awesome. You said understanding food. Tell me a little bit more about what that means. I'm assuming since you met at Clarifai, you're doing something visual?
Yes, exactly. So to understand the world's food, we need to be able to have examples of what people are eating day to day. And most ways that we communicate about food these days is with pictures. Mm-hmm. So we started by building an image recognition model that can understand what we're eating, which means that we can take something that we're eating and translate it into a set of tags and also give you nutritional information. And where we're going with that is actually we'd love to be able to take in other ways we talk about food. It could be through menus or through text and be able to say, hey, it's XYZ. It could be made with these ingredients. And we want to build a system that can let other people also be able to use the intelligence and understanding we have about food to power their food applications. So it could be a nutrition tracker in a healthcare setting. It could also be for a recipe website They have a bunch of pictures. They want to know what ingredients it is. That's kind of what we're working on.
Oh, interesting. Now, I don't know if you've come across Hillary Mason. She has a company called Fast Forward Labs here in New York that was actually recently acquired, but they do data science experiments, if you will. That's one of the things they do, at least. And they experimented with trying to do this, determine nutritional information based on pictures of food. And I think she mentioned this on a podcast I did with her. She said it was an incredibly difficult problem. Right. I think they end up giving up on it and moving on to something else. What are you doing differently that makes it tractable?
We kind of approach this from a consumer side with a product called Bitesnap. It's an app that helps people track what they're eating. Okay. Kind of like a MyFitnessPal alternative using images as input. Okay. What we do is every time a user comes in and wants to log a meal, they take a picture of their food. We give them suggestions of what it might be. Users are able to correct this, select a correct choice, or kind of pick something else that we didn't predict. Tell us the portion size. So every time someone logs a meal, we get training data to improve the algorithm. And what we do in the app now is if we take a picture of a meal that we haven't seen before, we can't recognize, we allow you to tell us what it is, and the algorithm learns to recognize it. So we do one-shot learning, so next time you come around, we can recognize it. And in doing this, we're collecting all this data. Users on our app take about 3 or 4 pictures a day. Okay. So we're going to have this human-in-the-loop system to help us keep improving.
Interesting. How do you measure accuracy?
On the image recognition or on the nutrition side?
On the nutrition side, like kind of the full loop.
So portion size is very important. And for now, we have the users tell us the portion size. So we have there's this big study called NHANES where the government collected all this data on what people eat, how much they eat. So we have kind of a distribution of, for example, fries, how many fries someone might eat for dinner. And we're using that as a prior, as like an example of what the portion size might be. Okay. We ask the users to correct that. Okay. So it's still on them to kind of tell us how much they ate because it's so crucial these days. I mean, just in general, to be able to measure food and get the accurate numbers, you have to be able to tell us how much there is. But we're hoping that by getting this data, later on, we can actually start using computer vision to predict the portion size.
Okay. I'll definitely be downloading this and playing around with this. So I've been experimenting with a ketogenic diet, which I use FitnessPal. Like if you're really into it, you're tracking your macronutrients with every meal, and it's a pain in the butt to do. And so I've experimented with just taking a picture of the things that I eat and then going back afterwards and then trying to look at it and figure out. And it's hard for me to figure out, okay, what the portion size was, but then also like, what the fat content was. If you go to a restaurant, the fat content in a given meal can vary, pretty dramatically. I mean, those aren't things that you can address just by training data because in most cases, the users don't even know themselves.
So we're hoping to use the data we collect from users and start integrating location into the system. So if you know that you go to Shake Shack and you have a burger at Shake Shack, and we've seen an example of that burger at Shake Shack and someone put in the information, we'll be able to say it's not just a generic burger, it's the Shake Shack burger with the nutrient data we get from their menu.
Okay. I was going to ask if you were targeting like chain types of meals it seems like that's easier than...
Yeah. So we haven't gotten to it yet, but it's kind of on our roadmap in the next few months. Okay. It's to kind of pull in that information, start using location, and kind of the other signals to improve the accuracy.
Okay. So tell me a little bit about what some of the big challenges have been for you.
I think for us, the biggest one is just, like you said, it's a hard problem. The coverage is an issue. People eat all kinds of foods. There's probably millions of combinations. And kind of the first experience in that matters. If someone comes in, they try it doesn't work the first time, they might not come back. So for us, making sure we have good coverage of all the foods and we have high accuracy and stuff to eat at home that's not at a restaurant menu is important.
Right. How about for you, Vinay?
I would say that for us, because we do have a consumer app, I think marketing is pretty difficult in the consumer space, and our background is a little more technical, so it's kind of new for us to be marketing a consumer app. And for us, if the more consumers we get, the more data we can get. So, we've been lucky with the Futures Lab. We've been getting advisors and help, but it's still kind of an ongoing process that we're learning how to actually market the app and get it out there.
Interesting. Can you talk a little bit about the pipelines that you've created to process all the data?
Yeah, sure. I mean, as we mentioned, we scraped a bunch of images. From that, we basically built our own tools to annotate and clean data. I guess Michael can fill in there.
We built this tool to pull in images, use active learning to help us quickly annotate millions of images. The two of us managed to annotate 3 million labeled images of the different foods.
The two of you labeled 3 million?
Yeah.
Over how long?
It was about a week.
Wow.
Yeah. So we use clustering and some classifiers to rank and be smart about how we're doing this.
Okay.
I've kind of done it before at Clarifai.
Yeah.
Kind of have an idea of how to handle this scale of a data set.
Okay.
And we went from a model of 60 classes to now a bit over 1,500 different foods. Now that the app is out, we're getting all this data from users as well. And we're starting to train on that data as well.
And you say 1,500 different foods. When I think about like how many different foods FitnessPal has in it, it's a multiple of that, isn't it?
Yeah. So there's two issues. There's whole foods that you might go get at a grocery store. Or there's homemade meals. Mm-hmm. That's what we're focused on right now.
Okay.
And most of these are basic ingredients. So if you take a plate of pasta, of tomatoes, we'll say it's we might say it's pasta. We'll also give you options for the noodles, the sauce, the cheese on top, and kind of break that down. Soon we want to also handle products. It's kind of doing the other side of it. This is where you get the millions of different products.
Right.
And for now, we added a barcode feature. You scan the barcode, it will tell you the nutrition information. You can take a picture of it. So now we get an example of the image. We know what it is. So in the future, we can start recognizing the products as well.
Okay. So kind of a combination between the food detection as well as like a Google look almost. Like identifying the products. Yeah. Interesting. And are you also allowing them to track the nutritional information over time? Is it kind of like playing that role as well, or just do they take the data and plug it into something else?
It's a full tracker, full logger. Logger will give you the breakdowns for the day, for the week, and you can see your history over time.
Okay. I need this.
Yeah.
And you should go after this keto market. Like there's I don't know, is that something that's on your radar? But...
We're actually getting feedback from our users. A lot of them are doing a ketogenic diet.
Okay.
And that's for us, the vision for the app in the future is to kind of build it up, to start putting communities together.
Yeah.
We have users who have all this content, they have pictures, we know that a person's a ketogenic diet. We might be able to connect them to other people who are doing keto, help them discover foods, share what they're eating, start recommending other stuff to them.
Okay. What are some of the techniques that you're using on the ML and AI side here?
So for image recognition, we're just using standard neural networks, convolutional neural nets. Still using Theano. Might have to switch into TensorFlow or PyTorch. For active learning, just simple like logistic regression. And just using logistic regression to rank the results based on the embeddings. Yeah, that's pretty much it. A lot of neural networks.
Okay. Cool. Where are you kind of in the life cycle? The product is out and on the various app stores, both. You're not going to tell me that you don't support Android, do you?
No, we actually do support iOS and Android. We realize that's incredibly important.
Okay.
So we're on both things because we're using React Native, which, for a small team, it really helps us because we can have an app that's available for both platforms. And in terms of the product, we actually launched an MVP earlier this year, and we've kind of been developing that towards kind of product market fit with other people. With other apps like MyFitnessPal, people have some expectations, so we're really, really close on kind of closing that out. And in terms of the product, we're now actually focusing to start launching an API so that people can use our technology in other applications.
Mm-hmm. Oh, that's interesting. I think I looked for an API for MyFitnessPal, and if there was one, it was like you had to submit a form and get approved and talk to their BD people, and it seemed like pretty painful.
Yeah, I mean, I think that because we're taking a little bit of a different approach in terms of our app, strategy, because we actually are fine with giving people macros and micronutrients. We find that the information is incredibly valuable for people to make decisions about what they're eating. So we're, offering that up. And, we do have plans and thoughts about opening up the API to users themselves so that they can be creative, so that they can view and visualize their data in their own ways. We've experimented with that because we can let you export to CSV or JSON. So you can pull that in and kind of build your own visualizations. And a few people from the self-quantified community are really excited about it because they can actually then, kind of make their own collages and their own charts and integrate that into their own, self-quantified solutions. Because, that's not our focus, but we would love to enable creativity for them around what they're eating. And that's kind of a big part of their life.
And so do you, thinking about, again, where you're coming from with Clarifai, do you see the Bitesnap product as kind of just bootstrapping an API business, or is that the product?
It's a core product for us, but we see that it's a great way to get data, to have this human in the loop system that keeps improving. We've gotten a lot of inbound requests for an API from customer research firms, from the healthcare side, from hospitals, people dealing with diabetic patients. So we're kind of looking to open that up to other people. There's a lot of core technology we're building up that other people use in other ways.
Okay. Interesting. Maybe we can spend some time and you can kind of walk me through the annotation framework that you built out for getting through those images. That's an impressive feat.
Yeah. The tool, pretty much, we get content from the web, or you have a classifier. Let's say you have a neural network that you trained before. What you do is you predict on all your images, you get some kind of ranking for each class. So let's say for strawberries, we'll take a classifier that's a weak classifier for strawberries, run all of our images through that, get a signal of what might be a strawberry. We use that to rank. We also do visual clustering. So we can say, for all these images of food, these are the similar looking cluster. For images of strawberries that are in the middle, there's 2 strawberries. We can look at that cluster, and for the whole cluster, make a response of, yes, this is a strawberry. Then we have a classifier that uses that input to train and improve. So now we can re-rank the results again. And once you get to a high enough accuracy, we can say for the rest of the image, because the classifier is 99% accurate, or let's say it's 95, just say, whatever the prediction is, assume that's a clean label.
Got it. So when you annotated 3 million images, like that initial, you look at the cluster of strawberries and say, yes, these are strawberries. Yeah. That might have knocked out 100,000 images for you, or some large number.
Right. So, but if you take the ranking for all the images for, let's say, the strawberries,
right,
you kind of see stuff on the bottom that's definitely not strawberries. So you can say, let's say the bottom 20% is negative data now. Right. You take the top 10%, if you look at it and see that it looks like positives, you assume that's positive, you update your classifier based on that data, and you retrain and re-rank again, kind of moving that data away and kind of keep diving into it. Clustering we found was working really well as well, because now you can, instead of looking at a single image at a time, you can say, for this cluster, all images look similar. They all look like strawberries. Yeah, I'm sure you've seen like clustering on the embedding space. So now you can, instead of responding to an image at a time, you can, for a whole cluster, say, yes, this is a strawberry, not a strawberry.
Okay.
And then have this active learning system, which will be able to pick out the next stuff to annotate.
And so you annotate your strawberries, and then you have all that information for kind of the next thing you're looking at. To what extent does the annotation for strawberries impact, bananas, if that's what you're doing next?
Doesn't at all. So you press restart again of bananas. Okay. It turns out the neural networks are very good at handling noise. So if you have a classifier you train on the dirty data, there's a 60% probability that the thing that mentions strawberry has strawberries in the image. If you train it, you're already getting a pretty good signal to recognize those items. So you can kind of bootstrap with that and then kind of keep improving it with the actual annotations. The other one for us is we'd like to be able to do segmentation or bounding boxes, but it's really expensive to get that data at scale. For us, we want to recognize thousands of different foods, and take us forever, and probably that's millions of dollars to actually annotate at that level.
So that's what I envisioned you were doing. So right now you're identifying images that have a single thing in them and using that to train.
So even if you have multiple items in an image, we'll do one class at a time.
Okay.
So we'll do multiple passes over it if it has multiple items.
Okay.
So most of the time with release stuff, it's 4 or 5 different items on the plate.
Right.
Or it would be a soda, a burger, and fries. So in an example like that, we'd do all the fries first. You might be able to pick up on correlation and say there's a burger as well, but we do one class at a time when we do this labeling.
When you say you look at the plate and you do all the fries first, are you talking about when you're training or when you're doing inference?
Oh, no, when we're doing the cleaning annotation stuff.
The cleaning annotation piece.
Yeah, but we're hoping that if the classifier is good, the next time we go around, the burger classifier picks it up, so we'll see that image again.
Right.
We will say if the burger prediction is correct or not.
Okay. And so this kind of iterative process, to what degree is it, have you automated all that into some kind of pipeline, or is it still, are you manually kicking off runs to do annotate for object X, or?
So we kind of have a batch job to do the initial annotations, but we have a system that's coded pretty much in Django with a React front end.
Okay.
That will take those annotations and then have a simpler class like an SVM or a logistic regression to do the ranking after. So once you have the initial suggestions for labels, it doesn't have to be a neural network. It could be just web data. If you pick up on keywords of strawberries and you have images on the website that also mentions strawberry, you kind of assume it's a weak label, has a chance of it having a strawberry. And so you index that, and in this database, you do the skins and kind of can go class by class.
Okay.
So that pretty much is automated.
Okay, interesting. And how about the crawling part? Were there any challenges involved in that, or was that pretty straightforward?
I mean, for the most part, it's not a challenge to download lots of stuff. Yeah. What the real challenge is actually getting decent labels. Yeah. And, we figured out some techniques to basically, the right sites in the right places that actually have decent labels. And we actually even took some unlabeled data so that we could actually supplement the weak labels we have. Mm-hmm. So we can get more examples, and that's kind of how we started. It's just, it takes a little bit of time to get it right.
Mm-hmm. Okay, interesting. What else are you doing that's cool and interesting and that we should know about?
So right now we have an issue with packaged products. We have a model that works well on Whole Foods. People seem pretty happy with it.
Okay.
But one, we don't have a huge database of barcode products, of scans, of nutrition data. Mm-hmm. So now we're also working on being able to use OCR and computer vision to kind of scan a product, be able to index it, be able to tell what brand it is, what the health claims are, what the ingredients are, just using computer vision. Another thing we're playing with is using ARKit and these AR technologies to do the portion size estimation.
Interesting.
So kind of, we have an intern working on an initial idea for this, but the idea is it will be, you take a picture, we'll get a point cloud, we have a user pick a portion size for now, but now we have a point cloud, we have the image, we can do some segmentation, and we have the portion size. So over time, we'll get more data to actually nail that part of the problem.
How does ARKit work? I haven't had a chance to look under the covers there.
We have an intern playing with it now. Okay. For now, you can get horizontal planes, and if you only get a point cloud. So for us, like when you have a camera open, not only will take a picture, but also try to record the point cloud, so we can get some depth information and figure out the size of the items.
Oh, interesting. And are you thinking about taking it the next step where you kind of project on top of use ARKit the way it's designed and project something on top of the plate that says don't eat this, or put an X over the fries?
Yeah, that'd be great.
I mean, we were, in terms of ARKit, we're playing with different user interfaces. So one is, like Mike was mentioning, is that we could project a cup to help you understand what a 12-ounce cup versus a 16-ounce cup is, and kind of put that next to each other so you can select, oh yeah, this is a pint glass versus this. There's another mode where maybe we need to also do measuring because it's not perfectly a cup or perfectly a plate. We can allow people to do measurement. I don't know if you've ever played with these measurement apps. They're pretty easy to use. That's kind of how we envision using AR now. I mean, in the future, if there were AR glasses, we'd actually love to be able to project the information that we know about food onto the real world. And that's a friction-free environment. Yeah. We're recording what you're eating, so you don't have to log. Because if you have another passive device absorbing that information, it can understand, hey, you're eating pizza with burgers today, maybe tomorrow you should eat something else. To feel better.
For us in general, the goal is to get to this very passive mode. Right now, we still give you suggestions, but for some classes, we're pretty much at human level accuracy. So kind of things like burgers, fries, when we predict it for the most part, it is accurate. Okay. So we don't want to get to a point where there's pretty much no user interaction. You take a picture or you have some glasses, you go about your day, where you're able to measure all this stuff about your diet, tell if there's weaknesses, tell you how to improve, kind of have this dashboard where you practically don't have to do any work. Okay. The other thing we've noticed is people tend to eat similar stuff every day. Mm-hmm. So soon we'll be able to predict what you ate before you eat. if you're at home, if you go to a coffee shop and you always have a latte at this coffee shop, we should be able to predict that you had it and log it for you without doing any of the work.
Like using location services, you just walked into Starbucks, should I add a pumpkin spice latte to your daily?
Yeah. And I'm doing it for you, just logging the meal before you.
Yeah, I mean, even actually for other meals, during the week, you usually eat XYZ, so why should you have to go and tap stuff? We can just kind of fill that in. Right. So that, the meals that really are different are the ones you have to actually log. We can actually kind of build part of that experience already now. We don't need necessarily AR or glasses. We can just do that based on location plus time, day, what meal it is.
So you mentioned some of the challenges you're seeing in terms of getting this out to market. What are the top, top 3 things that you feel like you need to be successful based on where you are now?
I would say that we need to have product market fit, relative to the other food logging apps. We just can't be, having features missing because people say, oh, I'm so used to this. I need it. That's that's a known. We know how to do it. It just takes us a little bit of time to get the features right and, make them look beautiful. I mean, that's another very important thing with consumer apps is that it has to look really good.
The bar is really high now.
Secondly, the thing is there is a lot of other apps in this space. And for us, they're incumbents. People know them by name brands like MyFitnessPal. So for us, we have to, become visible, and we probably have to become visible through other channels than just pure search, because most people are searching for those name brands. So I think those are kind of our top 2 challenges in terms of marketing getting the app out there.
Mm-hmm. And on the tech side?
Data is always, for us, it's always about having data. So there's Right now, for some of the classes that we predict, we don't have the nutrition data. So we don't even show a suggestion. So we might be able to predict the item. But because we don't have nutrition data tied to it, we don't even show that prediction to users. So
and did you gather a database of nutrition data by searching and that kind of thing, or by just finding a database?
So the USDA has a very big and detailed data set. Okay. It's about 100,000 different common things people eat in America.
Oh, wow.
And it's broken down by ingredients, the common portion sizes. It has the full nutritional breakdown. So we're using that for now.
Okay.
But now we're working on ways to pull in restaurant data, to pull in product data, and kind of help us increase that database.
Okay.
I mean, a shout out to the USDA. They do really good work. Their nutrition database is quite complete. What's interesting is actually we learned that other nutrition databases for other countries actually depend on the USDA database. They actually have references to the English database, and that's long-term international expansion is a little bit more tougher problem for us than most people. We have to convert our labels, so the things that we call pizza is probably universal, but in the morning pastries people call those things different things in different languages. We have to do all that translation. Not only that, with the nutritional facts, there's regional variations with how things are prepared, and then of course regional dishes, which actually vary by look depending on where you are. And we've been getting a lot of requests from international users. Hey, can you recognize XYZ for me? And we're like, we don't even know what that is.
Nice. Yeah, I mean, there's so many challenges there, all kinds of foods that are, look like one thing on the outside, but they have stuff inside.
Yeah.
Right.
The nice part about having this app that you get to control yourself is that we get to consider correlations, we get to see eating patterns, and use other signals to improve the predictions. Based on the time of day, we can say this is probably a coffee, not, let's say, hot chocolate, kind of using other signals to improve the predictions. We were hoping that at one point we'll be able to say, given that you selected these 4 ingredients, we can figure out the portion size based on how we see it correlating.
Okay.
Yeah, I mean, just basically taking a recipe, the ratios. Yeah. And this is actually this is actually integrated into some of the USDA data. They have some internal equations. Basically from that we realized, hey, you can actually take recipes and understand what the ratios are, and we can integrate that to things that other new things that we learn about from restaurant menus or from web recipes, which makes it even easier to log. You just take a picture. Oh, this sandwich is probably these things, and for most people that accuracy is great, because otherwise they have no nutritional information in front of them.
Okay, awesome. Well, Vinay and Michael, thanks so much for taking the time to chat with us. Really appreciate it and really enjoyed learning about your company.
Cool. Yeah, thank you for your time.
Thanks.
All right, everyone, that's our show for today. Thanks so much for listening and for your continued feedback and support. For more information on Michael, Vinay, Bite.ai, or any of the topics covered in this episode, head on over to TWiMLai.com/talk/65. To follow along with the NYU Future Labs AI Summit series, which will be piping to your favorite podcatcher all week, visit TWiMLai.com/AI Nexus Lab 2. Of course, you can send along your feedback or questions via Twitter to @TWiMLAI or @SamCharrington, or leave a comment right on the show notes page. Thanks again to NYU Future Lab for their sponsorship of the show. For more information on the AI Nexus Lab program, visit futurelabs.nyc. And of course, thanks again for listening, and catch you next time.